Okay. Now, okay. We can all see what I'm sharing, right? Yes, Nicole, I see your hand. Your hand is up. Okay, thanks, Amanda.
Morning.
How are you, Nicole?
I'm good. How are you, sir?
I'm good. What's up?
Before you start, could you just please let us know what is coming in test one? Because our lectures at Damlin are very confused if we should follow that pacer week 1 to week 5 in test one, or if we're following the old thing paper that they sent us. So please just confirm what's in test one, please.
Okay. Thank you, Nicole. Let me see if I can just try and share the pacer that I have. Okay. Just give me a moment. I just want to find my pacer that I have, and then I will share that with you guys. Where is it? Where is my pacer? Okay. Thanks. Just a moment. I'm just going there now. Just a minute. Okay, from the test one, which sample coordination test, it's actually starting. It should be like in what, in 3 weeks time, right? Maths and 6 Go Digital. Okay. Okay, can I share it? Can I send it on the chat? Is that okay? Can everyone access the chat on this lesson here, so that I can send it there? Would that be okay?
Yes, that should be fine.
Sir. Good morning, sir. I can't access the chat.
Okay, it's fine. If you can't, let me try and just show you here. But okay, it's here now. Okay, good. Okay, it's a 2-page document. Let me share. Where are you? Yeah. Okay, I'm now sharing it. Okay, it's just showing the first page. I'm going to also go to the second page, but if you look at the first page, it's basically saying that you guys are, is correct what Nicole was saying. It's actually module 1 to module 5. Okay, but not everything on module 5. Okay, because module 5 is quite long. It's about 40%. Is the longest module from Maths N6. It's about 40%. Other ones are 12%, 18, 12%, 16, 6%, 8%. So it's quite long. So this is the first part, right? The first page I'm showing you. It shows differentiation, integration, partial fractions, differential equations, and then this is module 4, right? Module 1 is differentiation, module 2 is integration, module 3 is partial fractions, module 4 is differential equations. And then if I go to the second page, okay, this is the second page here. It shows that we are going up to, or basically it's, in fact, it's all of module 5 as well, eh? Okay, besides depth of center of pressure. So you can see that the national test, according to my PESA, it's 1 Feb to 5 Feb. Okay, and it's covering up to area moments, second area moments, volume moments, moment of inertia. That's what it's covering up to. And then the last 3 sections, everything else will be included in the DP, which is test 2. Okay, test 1 is covering up to moment of inertia. Is that okay, Nicole? Is that okay?
So what I'm confused about, you see where it says February, 1st February to 5th February, where it
Yes.
says national test. It says at the bottom, national test will cover week 1 to week 5 chapters. And doesn't week 5 chapter end at, I think it's
Okay, I'm actually looking at it. That's a bit confusing now because I don't know why it says week 1 to week 5 when you'd have learned things up to week 11, you know, and then you're saying week 1 to week 5. Oh, that's a bit tricky. Okay. Okay, what I'll do is, guys, I will give you feedback. We're having a class on Monday, right? I'll give you feedback. The only challenging part is I only have a few lecturers that I know that I can contact from other branches. I don't have everyone's contact details for the other lecturers, but if you could, everyone, if you could let your lecturers get in touch with me, then Monday when you're having our lesson, I'll let you know. I would have sorted it out because I read the pace, I know it, but this part I was not aware of this week 1 to week 5 part. I'm only seeing it now, and I've never. The way we've always done the PACER is when you do the PACER, the test 1, it covers the week before the test. That's how it has always been done. So I'm actually surprised that it's kind of like set up like this. But I'll let you know on Monday the final thing of how it's going to be. Okay, I hope that's okay with everyone.
okay, thank you, sir. Yes.
Okay. Okay, thanks for that question. It's Nicole brought it up. Thanks for that question. I'm going to look at it, troubleshoot it, then I'll tell everyone Monday what's going to happen on that. Okay. So I don't know. I'm still sharing the PACER. Now let's just go to the slide. Okay, for our lesson for today. Okay, there we are. So today we're looking at area moments, centroids, and second moment of area. Now, basically, if you are calculating area moment about an axis, the formula is always given as RDA. Okay, And then if you want to calculate centroid, it's area moment divide area. So anyone who wants to calculate centroid, they would have calculated area moment first.
Next. Excel. The castle corner, boy.
So if you're calculating centroid, it's area moment divide area. And then if you're calculating second area moment, it's R squared dA. So this is what they give you in the formula sheet. They just give you R dA or R squared dA. Now the value of R, you literally have to know it for yourself. Justice, I've muted you. Please don't unmute. Okay, so area moment, they just give you RDA. Okay, so you need to know what is value of R. We're going to go just do 1 or 2 examples that I show you how we go about it. Just for the area moment, okay, which is first area moment. So, now this is it's a diagram of a single curve. Okay, remember you can find 1 curve or 2 curves when you're dealing with module 5. You know, just like if you're calculating area, you can find area under a curve or area between 2 curves. Okay, so here I'm dealing with area under a curve. Now the limits are in the x-axis. You can see the limits here, A and B. Okay, so this graph, it's a y graph. Limits are in the x-axis. Okay, now I'm just showing you. I'm just showing you the case where the limits are in the x-axis. Now, if the limits are in the y-axis, you're just going to change the values, like your x becomes your y becomes your x. Okay, so if you know the example when the limits are in the x-axis, and then you can also know, you can also do any question when the limits are in the y-axis. For example, if area, let's say, let me write it down, right? Let's say I'm looking for area in the x-axis for this graph here. Limits in the x, it will be what? Integral of y with respect to x. Okay, but if the graph was in the y-axis, if the limits were in the y-axis, it would be x dy. Do you understand it? If I was looking for, if my graph was, limits were in the y-axis, it would be area is x dy. So you just, if you know x-axis, limits in the x, you can know limits in the y. That's what I'm trying to say. Okay, you see it for yourself when you're doing, when I show you the formula. Now let's go back to here, our graph. Now, something important. When you're looking for area moment, I take a point on the strip, right? On the center of the strip there. Now, the distance from the y-axis, it is going to be an x, this one here. And then the distance from the x-axis, it will be half y. Okay, why is it half y? Because this full distance of the strip, it's actually y. Okay, the full distance is actually y. That full distance there. So the point that I use to find area moment is on the middle of the strip. Okay, so from the y-axis, it's the distance is x, but from the x-axis it's half y. Okay, so you need to remember this when you are dealing with area moment. We use this for area moment, so you need to remember it. It's x from the y-axis and it's half y. Remember, this is a single graph. So let's go. So this is my formula for area moment. In the formula sheet, this is what they give you. Only, they don't give you anything else more than that. They just tell you area moment is RDA. So now, if you're calculating area moment, you can calculate area moment about the x-axis or area moment about the y-axis. Right, you can calculate, they can ask you area moment about the x, area moment about the y. So let's say they asked me area moment about the y-axis. If they asked area moment about the y-axis, my r, it would be x. Remember, I showed you that this is my r. Yeah. So my r will be x. Okay, because we're looking, basically we're talking about the distance from the y-axis. R is the distance from the axis that you're talking about. So if you're dealing with the y-axis here, my r will be x. So what does it mean? It actually means my area moment is going to be x times. Now dA is area, delta A is the area, and we know that the area of a graph under the y, with respect to the x-axis, it's y dx. Okay, I showed you already at the top here. I showed you at the top there. Right, this one here. So this is my r here, and this is my dA. Okay, so you need to know area of a graph. Area of a graph in the limits in the x-axis is y dx. So it means basically this is how I calculate my area moment. It will be xy dx. Now this y here, you are going to remove it and put the equation for the y-axis they gave you. If they told you y is x squared, it means you remove that y and you put x squared. If they told you y is sine x, you remove that y and you put sine x. Okay. Any questions on this first part here? Okay, as I always say that you know, with maths, it's many times it makes more sense when you start to practice it. Okay, so just try and understand it the way I explained it. Obviously, I know you guys should be writing notes. Write down the notes, what I'm saying. Okay, write down notes. Although it's a virtual class, it's an online class, you still have to write down notes. Okay, so this is the first part when I'm looking for area moment about the y-axis. Limits are in the x-axis. So whenever I calculate the area moment, you need to know where are your limits and about which axis is it up. Your limit, are your limits in the x or in the y, and it's area moment about with reference to which axis. Okay, so in this first part, my limits are in the x, but I'm looking for area moment about the y. Okay, so let's do the second part. Sorry. Let me, sorry, I just want to jump to somewhere that I need to get to. Oh, okay, my other slide was, I can't see my other slide. Okay, just look at that slide, guys. I just want to check what happened to my other slide that I had. Oh, okay, I'm just trying to quickly type it out. I don't know what happened to it, why it disappeared. Why it disappeared on me, so I'm just quickly typing it out here. Okay, I'm just going to remove the slide a bit, and then I reload it again. Just give me a minute. So that was the first part that we did. Okay. Now the second part, which you're going to do, it's coming up just now. Okay, there it is here. PowerPoint. Okay, so now this is the same graph. Okay, the formula is the same. Area moment is equals to RDA, but now we're dealing with area moment about the x-axis. Okay, just the previous slide, we're dealing with area moment about the y-axis. Remember, in these both cases, my limits are in the x. Okay, so always take note, my limits are in the x, but I can find area moment about the y or area moment about the x when my limits are in the x. If your limits are in the y, you can also find area moment about the x, area moment about the y. Okay, so here we're dealing with area limits in the x-axis. So if I'm finding area moment about the x-axis, my r is going to be this one here, half y. Okay, I've already explained why it's half y, but I can explain it again. I said whenever I draw my strip, this is my strip here. Okay, this is my strip here. Right. The coordinates of my strip is xy at the top of the strip, where the graph is xy. But when I'm dealing with area moment, I deal with at the center of the strip here. So the y coordinate at the center of the strip is half y. Okay, but the x coordinate from the y-x is just x. It's not half x, just x. Okay, so always keep that in mind. Try and remember that all the time. So that's why I'm using half y. So now if you look, it means my area moment is going to be half y times y dx. This is my r here, which is half y. And this is my dA here, my calculation of area of a graph. Okay, so you just put y dx because area of a graph in the limits in the x-axis is y dx. Then if I simplify it, I get half y squared. Okay, so I've just shown you ways to calculate area moment about the y-axis and area moment about the x-axis when your limits are in the x. Okay, so remember that. Okay, the first two that I've shown you, remember them. Remember what I explained to you. If you are dealing with the y-axis, everything just going to go reverse. Okay, there's a formula sheet that I'm going to show you which shows the ones even for the y-axis. Okay, I didn't want to do them here because of time. So, any questions on this part when you're dealing with the about the x-axis? Okay, let me go to the next slide, right? I hope we got this slide. Remember, I told you you need to write down the notes. The graph, you can just do a quick sketch of the graph, but by now you've written down all the notes there. Okay, if you're not that fast, you can take a picture. Okay, use your phone, take a picture, then you can write the notes later. Okay. Now, this graph here is now two graphs, not one graph. Okay, it's two graphs. The top is y1, the bottom is y2. And still we're talking about limits in the x-axis. Okay, so it's two graphs, the limits are still in the x-axis. Okay, so what do we do here? Again, look at this now. From the y-axis, it is still, my distance is still x. It doesn't change. But from the x-axis, the distance is half y1 plus y2. Remember, it's at the middle here part. Is that okay? So the distance between these two if you want to find the distance between two lines or 2 points, you just add them and divide by 2. Okay. Example, the distance between, like if it was distance between A and B, the middle part is A plus B divided by 2. That's how I find the distance between 2 points. So here we have two graphs, y1 and y2. The distance between them, the middle point, not distance, the middle point is half y1 plus y2. Okay, so that's how we get that half y1 plus y2. To find middle points between two lines or two lines or two graphs is simply half of the sum. Okay, if you remember when you're dealing with whoever did N3, you know, and you're looking for the middle point between, on a straight line, the middle point between 2 points on a line is simply you add the 2 points, then divide by 2. Okay, it will be x1 plus x2 divided by 2. And then the y coordinate is y1 plus y2 divided by 2, which is same as half y1 plus y2. Okay, so that's how we find that half y1 plus y2. Now let's go. Again, they just give you that formula. At the moment is, even if it's two graphs, they just give you that formula there. Okay, but we know that if it's about the y-axis, our r will be x. I showed you already, right? There it is here. Okay, but what is our delta A? Delta A is area between two graphs. What is area between two graphs? Let me write it here, right, before I even put it on the slide. Area between two graphs is equals to y1 minus y2 in brackets with respect to x. Okay, so that's delta A. Okay, so we know our R, we know our delta A. So let's put it there. So there you go. So that's how I calculate my area moment. It is equals to x times y1 minus y2 with respect to x. So remember what I told you, you put your y1 there, your y2 there, and then you integrate. Okay, so this is the formula for area moment about the y-axis. If it's two graphs and the limits are in the x-axis. Okay, I'll just a few seconds for you guys to look at it. And then I'll move to the next slide. Is just going to show it's still two graphs, but it will show when it's about the x-axis. Okay. I'm really hoping that we can jump. We have enough time to do. We have enough time for a thing. We have enough time for an example. We're going to do maybe at least one example, okay, so that we are aware of what we're doing. Okay, let me go to the next slide, right? I hope I'm not too fast. Now, the next slide, the graph is still the same, okay, but now we're looking for area moment about the x-axis. So I told you that our R is half y1 plus y2. Okay. From there, area moment, this is my R here. That's my R. And then all this part is my dA. Okay, so you can see what is my R, what is my dA. Now, I can combine these together. How do I combine it? Remember, I can use difference of two squares. y1 plus y2 times y1 minus y2, it is same as y1 squared minus y2 squared. So that's my formula for area moment about the x-axis where my limits are in the x. Okay. So it's this just as I told you, I was just showing you only for the x-axis. The next slide is going to show you all the formulas. All the formulas that are there that I have now. If I show you those formulas, it's what I compiled for students so that they understand, but it's not what is on the formula sheet. I always have to remind everyone that. See, because I thought, let me design a formula sheet for students to use when they are learning, but they can't use it in the exam because it's not part of the formula sheet for the DH. Personally, I think department should have done more with the formulas for N6, but you know what, it doesn't matter. Whatever they give us, we use that to get our distinctions. Okay, we just have to practice these formulas. Don't try and cram. Okay, practice it. Do some questions and go back to the formula, look at it, try it, write it down. I always say to people, if you're trying something, write it down. After you've started, write it down, see if you know the formula, then go and check. Don't just say, I don't remember, you check. Without ever write it down, then mark yourself incorrect. Okay, let me move on to the next slide, right? I don't see any questions, any hands up for now, which is good. Hopefully after the... Yes.
Yeah, I'm Daniel.
Yeah, I can see Daniel.
Okay, I want to ask, is this the same what we did in N5? The same way?
Yes. I'm I'm trying to think of the N5 syllabus. Just give me, I've got my N5 textbook somewhere close by. I just want to double check and make sure that we're talking about the same thing. I've got my textbook for N5, just one moment. But it should be the same because, okay, N5 is talking about calculating moments. It's the same one, Daniel. It's the same one because you know why? Error moments are the same. So I can see for N5, for N5, it's a bit more easy in the sense that it's, they want you to just to derive from first principles. Okay, so N5, you're deriving, it only asks for second moment of area, not first moment for N5. That's number one. And number two, you're just deriving from first principles, you're not doing any calculations. Okay, so yes, it's correct, but this what we're doing is first moment. We are going to do second moment as well. But N5, they ask you to derive second moment of area, and then they ask you to derive second moment of inertia. Okay, so thank you, Daniel, for that. It is more or less the same. That's correct. Okay, let's go to the next slide. Now, if you look at this, now this shows you all the formulas. Okay, as I told you that if you look at a formula sheet for Maths N6, it only shows you for area moment, it only shows you RDA. But I've tried to break it down, say for one graph, limits are in the X, limits are in the Y. For two graphs with limits in the X limit, I've tried to break it down for my students so that you guys get to understand it. But you won't get a formula like this in the exam because department, they don't give it like this. I think they should have given it like that. If you look at some subjects like power machines, it is even 12 pages, 11 pages of formula sheets and stuff like that. But for math, they didn't do it. But anyways, it doesn't matter. You guys are going to practice it until you know what, you understand it and it makes it more sense. Okay, so don't be scared. Don't freak out at all. I know many people, they kind of they freak out when they see it. Only thing you're going to do is to practice. Practice as many questions as you can so that you are comfortable. If you practice it, I can assure you, you'll get it right. It will be so easy, it will be just like this. A simple example, right? If you look at these formulas, the part where it says DA, you don't have to, DA, you should know area for one graph, area for two graphs. So that part, you don't even have to worry about it. Only thing you're trying to remember is what is my distance, what is my R? That's the only thing you have to try and remember, what is my R? Otherwise, the DA part, it's okay, it's easy. Okay, so one of the things, let me just tell you a trick. If your limits are in the x-axis and you're looking for area moment about the y, your r is always x. Okay, if your limits are in the y-axis and you're looking for area moment about the x, your r is always y. It's kind of things that I myself, I already know. You know, I taught myself that and I know it so well. Okay, so remember what I was explaining to you?
Sorry, sir.
Yes.
I didn't get you well when you say if you are looking for the moment area about x-axis, so I didn't get you well.
I was just explaining what you're doing. You know, you see what you're doing in the previous slides to say, let's just go back one moment. If you look at, you see here, although there are two graphs, if I'm looking for area moment about the y-axis, my r will be x from this graph here. Okay, so if if I can try and sketch, okay, let me do for one graph, okay? Let me just go back and I do for one graph. If, let's say this is my graph, like this, my limits are in the y-axis. Okay, this is my graph, shaded graph. Then I draw my strip. This is my strip here. Okay, this distance here is y. Okay, and then the distance from the y-axis here, it will be half x. Do you see it? So if you compare what I've drawn and what is there, you can see that if I change the limits, instead of having x, it's half x and this part is y. That's what I was meaning.
All right, sir. All right.
Okay. So I'm just going to go forward to our formulas that we're doing, that I was showing you. Okay, so these are the formulas, right? As I said, take a picture of it, right? If ever, I think I got a PDF format of this. I can send to anyone who needs it. I'm trying to remember where I put it. I would have shared it somewhere, but if you want, I think Monday I'll try and find where I put this, and then I'll try and share it. Okay. But I always say this to students: this is to help you practice. The moment after you practice, you should now learn them, because in the final exams you don't get this formula sheet. You get the one from the department. So this is to help you practice, but the more you practice, you won't even need this. You'll be able to know it by yourself. That's the key of that. So please always take note. And like you can see at the bottom there, centroids. If you're looking for centroid with respect to x, x bar is a moment about y over a. So if I showed you the first formula, looking for centroids, it's area moment divide area. Okay, so it shows you at the bottom there. Let's say your limits are in the x-axis. This, let's say what I've highlighted here. Okay, this is what I've highlighted here. If your centroid is with respect to the y-axis, then you'll be looking for x bar, which is area moment about the y divide area. If you're looking for a centroid with respect to the x-axis, it will be y bar divide area moment about x over a. Okay, so you look at all this and then it helps you. Okay, we have about 15 minutes, so, and then this, okay, this is for second moment of area, okay? Just try and take a peek of that as well, and then just keep it, right? So that you guys will remember it. Okay, so we have to go to the example, right, guys? Because of, I want us to finish at least one example. Now, this is the example. calculate the points of intersection of y squared is equals to 32x and y is 2x squared. Sketch the graphs and show the area bounded by the two graphs. Show the representative strip perpendicular to the x-axis. That we use to calculate the area, and then 1.2 calculate the area, 1.3 calculate the area moment, as well as the distance of the centroid. Okay, so this is what we have. Okay, just look at the question. So I hope everyone is looking at the question. Okay, I should take a picture because it's quite a long question, right? Now, let's look at how we do it. The first part, we're just going to go through it quickly because I don't think it's that much of a challenge. They want us to find points of intersection. So what I did is, you see this y value, I took it and placed it inside that first equation there. That's the way I did it. Okay. So that's how I came up with this part. I took the second y value and put it into the first y value. And then I simplified. I collected everything on one side. And then I factorized, I used difference of cubes, and I got my two answers for x. Okay, so this is just finding points of intersection. Okay, and then obviously you also put the y value. So when x is 0, y is 0, when x is 2, y is 8. Okay, so that's the first part. Now, believe it or not, you only get like 2 ticks. Remember, for N6, 1 mark is worth 2 ticks. They actually mark out of 200, right? I've mentioned before. So if a question is saying 2 marks, it's actually 4 ticks. So here, this question will be having 1 mark, which means 2 ticks. So literally, they mark the last 2 answers, but they still want to see the working. Unfortunate part, they still want to see the working. If you don't put the working, you just put the answer, they won't mark it. But they won't give you any marks for the working. Okay, it's okay because it's N6 level, so it's got high standards. They still want to show all this, but they won't give you marks for such simple working. Okay, so this is the first part. Okay, we're not going to worry too much about it, but that's how you do it. Now, this is our graph, our 2 graphs. Okay, the first one says y squared is 32x on top. The bottom one says y is 2x squared. Then I showed our points of intersection. The first one is on the origin, 0 and 0. The second one is at 2 and 8. Okay, now when sketching a graph, you don't have to be very, very neat. Okay, you guys can see that it's actually you can see that it's actually what? The two are parabolas, okay? One is in the, it's kind of like facing up, other one is facing the right-hand side, okay? So I drew the parabolas and then my strip, the emphasis on the strip. See, if you look at this graph, look at these two graphs, you can draw your strip in the facing the x-axis, or you can draw it facing the y-axis. There are some two graphs that you can, there are some cases that your strip can be both in the x or in the y. Okay, it's possible to have cases like that. And then it's also possible to have cases where your strip can only be in one direction, not in two. But in this case, okay, just had some, I thought somebody had a question, someone's mic was on. Okay, so next part, after we drew, after this is what we, this is the graph that we drew, right? Next part now, there's find area. Whose mic is on? Someone's mic is on. Is anyone the question? Okay, I guess not. So how do you find area? Area is y1 minus y2. Okay, yes, you can ask Mashudu.
I just want to take a picture from the very first slide of the solution. Can you please do that?
Okay, which one? This part?
Yes, sir.
Okay, you can take a pic, it's okay.
Thank you.
I think you're done. Okay, yeah, another question. You can ask Dinadam.
Sir, I wanted to ask, how do you know which is y1 and y2?
Okay, that's a good question. How do you know which is y1, which is y2? It's actually an interesting question, right? Dinadam. Why is it interesting? Because I'm just going to use this slide, right? Let's say I draw like this. I got two graphs. I draw them like this and then like that. Okay. You see, when I do it, I choose the top as y1 and the bottom as y2. Right. And if you look at the formula sheet for Maths N6, I got a question paper here for Maths N6 somewhere. Nope, I must have it somewhere. Oh, okay. I don't know why I put my Maths N6 paper. It's not here. It's not here. It's not here. Okay, I must have left it home. Okay. But if you look at a Maths N6 formula sheet, they actually say area is y1 minus y2. They will be saying on the top it's y1 and on the bottom is what? It's y2. Okay, but if you look at some textbooks, they actually put y2 at the top and y1 at the bottom. See, so some students will be confused, like say, textbook is saying y2 is at the top, y1 at the bottom, but you are saying y1 at the top, y2 at the bottom. The fact is, it doesn't matter. If I put y1 at the top, then my formula for area will be equals to y1 minus y2. Okay, with respect to x. If it's volume, it will be pi y1 squared minus y2 squared. But if I decide, let me use a different color. If I decide to say y2 is at the top, and y1 is at the bottom. It means my area will be equals to, open bracket, y2 minus y1. Do you see that? So whatever graph is at the top is what you start with if you're calculating area or if you're calculating volume. So it doesn't really matter. I prefer that people stick with one standard, like for yourself. If you're studying for yourself, stick with one standard and say, okay, me, I'm always going to use y1 on top, so that your formulas, you know that your formula is always y1 minus y2. Okay, so you can even put y2 on top, but you have to change your formula for area and for volume. So I hope you answered, Dinadam.
Yeah, it's okay. Thanks, sir.
Okay, so let's quickly go. We have about 2 minutes. Okay, so this part we've done, and then, oh, sorry. Okay, so this is our calculate area. Okay, area is y1 minus y2. And then my y1, now remember, I have to make y sub the formula. So I know that y squared, not this. Y squared was equals to 32x. So I made y sub the formula. That's how I got this part here for y1. Okay, and if you simplify, you get this. Okay, y2 is straightforward. Y2 is 2x squared. That's straightforward. Okay, and then you need to integrate all of this now. Okay, we just about a few minutes, but we have to finish example number 1. Definitely, we can't go without finishing it. Okay, can I go to the next slide? Just to finish up this area thing. So the next slide, it shows us the calculation and the final answer. Okay.
Please, sir.
Now, yes.
Please, sir, can you go back to the previous slides, please?
Okay. Okay, there you go.
Thank you.
Okay, I hope you guys are taking I have to remove my video as well. I don't know. I'm thinking that maybe my video might actually be. Okay, the next slide shows us how we calculated the area and all this stuff. Okay, so that's area. Now let's go to area moment. This is the part that I really want us to do. Now, the limits are in the x-axis, and we're looking for area moment about the x-axis. You see, actually, like for you guys to understand it. Oh, I like to put video, man. I'm hoping it doesn't slow it down. For you guys to understand it, I actually had to write it down to say you should always do that as well when you're answering, just for you to know what you're dealing with. Write it down. So okay, where are my limits in the x-axis? Okay, write it down. What am I looking for? I'm looking for area moment about the x-axis. You write it down. Then you put the formula. And then remember what we showed to say if limits are in the x and area moment about the x, this is what we do. Then if we simplify it, this is what we get. Okay, so if you look at it, you see that this is what we discussed, what we talked about, and what we discussed when you're starting the lesson. Okay. Can I move on to the next slide? I think what I'll do these days, I'll actually connect to my phone so I have an idea of how fast these slides are going. Okay, I can actually see how my slides are because I'm looking at it on my other phone as well. It makes it easier. Okay, so guys, now, this is now how we do the calculation. Sorry. So look at that now. So this is what we do now for the calculation. Okay, so you saw what we did, right? I put my y1 and my 2, they're squared. Why are they squared? If you remember what I showed you on the beginning of the lesson, if your limits are in the x and it's about the x-axis as well, it will end up being like this. And then if it ends up being like this, you just simplify it. Now from here, it's easy to just do the integration. Okay, you just do the integration from there. Then you're going to get your answer as okay. I think I need to go back to the previous slide. Okay, just a few more seconds on the previous slide so that you can get to see what we're doing. This is the last slide for area moment. Now, to calculate centroid, it's area moment divide area. Right. So this is how we calculate the centroid. Area moment divide area and get our answer there.
Sir?
Yes?
Can you go back to the previous slide? Thank you.
Okay. Sorry. I'm just trying to finish up the lesson. Okay. As others are copying that, right? What I'm going to do is I'm going to I'm going to give you guys homework to do. Okay, I think I have 2 more examples that I have on area moment, but instead of doing them next week on Monday, I'll give you guys as homework, and then maybe I'll just give you the answers and you just compare what you got. Okay, and then you can see what you got with what I got. Okay, this PowerPoint is also on my class. So you can also find this PowerPoint in my class. Then you can check the answers to the other 2 examples. Right, so that you are aware of although I've done a few alterations to it, but the examples, I didn't change anything on the examples. Okay, I think you're done, right? So this is the last slide here for that example 1, that is. Okay, we have exceeded our time a lot. Please copy this down, take a picture of this, and then I'm going to give you the 2 examples I want you to do. It will be like homework you're doing over the weekend, right? And then Monday we'll look at something else, and then I will take it up and see from there. Okay, I always have to count down like 30 seconds in my head before I go to the next slide or so. Okay, okay, so this is example number 2. Please take a picture of it and you try it by yourself. Okay, then I'm going to show you example number 3. If I think I have example 3, I'll also give you, then you try it also. Okay, it's kind of like a homework you try, and then after I've tried it, Monday, I'll just give you the answers. I might not show you everything. I'll just give you the answers, then just see how you did from there. Okay, if anyone's got any questions on it on Monday on the homework, you can ask as well, right? Before we start something new, we just discuss a bit about the homework. Oh, sorry, I'm even showing part of the answer. So this is example 2. Can I go to example 3? Let me wait a minute before 30 seconds before I go to example 3. Okay, I think 30 seconds is up. Let me rush to example number 3. Okay, to be rushing through all the solutions. So you're not supposed to see all this. You're not supposed to see. Oh. Okay, so this is example number 3 here. Okay, guys, basically we're done for today. Let me just have a quick ask before we go. I just need a pen. Sorry, man, I found a quick ask before we go, so that, because I'm just trying to see if I can contact some of your lecturers, right, to try and clarify this thing about the test, how far the test is going. But you know what? Guys, I've just confirmed. Test 1, which is national test, it will cover week 1 to week 5. Okay, so it won't go to week 11. Okay, I decided, you know what, this is what the PES is saying. We stick with what the PES is saying. So your lectures are correct. It's week 1 to week 5. So the first test, it's only week 1 to week 5. Please prepare only for that. Okay, take note of that and prepare for that. I was going to tell you on Monday, but I thought about it and I said, no, you don't have to wait even until Monday. Okay, guys, our lesson is done. Thank you so much for coming. Thank you so much for attending. I missed you guys. I missed our lessons. Whew. I will see you on Monday. Same place, same time. I'm out.
Thank you, sir.